Hey guys, welcome to day 37 of Codeforces Everyday until GM. Let's just jump straight into some problem solving. We are at problem 77 on the A2OJ ladder, just trying to finish up this section as fast as possible so we can move on. But yeah, okay. Increase and decrease. Polycarpus has an array consisting of integers. Okay. Likes it when the numbers in an array match. That's why he wants the array to have as many equal numbers as possible. Okay. Chooses two elements of the array, AI, AJ. He increases number AI by 1, decreases by 1. So this sounds like sorting or something. Oh, this is 1300 problem. Okay. Given the operation changes exactly two distinct array elements, Polycarpus can apply the described operation an infinite number of times. Okay. Now the maximum number of equal array elements he can get. This sounds kind of difficult, just because there is a few different types, or like a few different scenarios we can run into. List map and int input split. And okay, I definitely am gonna need a whiteboard for this. So let's pull this over here. So, okay. So the question itself is pretty not confusing, I would say. We take in an integer, it's the length of the array, and we want to see how many equal elements in the array we can have. We can do that by picking two elements, adding one to it, and decreasing one to the other. So, yeah. Let me see. Let me think. So case one, there's one because no matter how you operate on this, you will get two different numbers, and we will always choose a larger number to do the -1 and a smaller number to do the +1, right? Now, for this case, somehow we can get all of them to 3. So subtract 1 from 4 plus 1, that becomes 1, 3, 2, and then 2, 2, 2. Right, okay. So it seems okay. To me, the answer seems like an average. Because the average of 141 is 3, and when you average, you're kind of like just moving like all the, like if we model 1 for 1 as blocks, it's like 1 for 1. When you average, you kind of just move the top blocks down to the bottom blocks, and then in this case here where it's 2, 1, we can't really move these blocks anywhere. So average is basically the sum divided by n, which this case would be 6 divided by 3, which is 2. But that's not that. Oh, 2 is the height of every element. What are we outputting? The maximum number of equal elements. in the array. So 2 is the average height of every element. Three, sum is, if the sum is odd, then we will always have one element that we can't make a block of average with. So I'm looking for like this special edge case where I'm basically trying to figure out if this case can exist where we have let's just use these over here. There's blocks of 2, and then we're left with like, I don't know, like 4 and 1. Oh, well, we can always make it. Okay, so I don't think so. I don't think there's ever a case like that where we can't make an or we can't group together a like 2 blocks. We can always make a block. Okay, here's a not so great thing. We can't make this its own block, right? So so when it's odd, how many is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The average, and this is 5. The average is 2. So since it's odd, we have one block that can't be made the average, which means our answer is sum, which is 11, divided by 2, which is the average. So sum divided by average minus 1. If it's even, it's just sum divided by average. So if it was 10, it'd be 10 divided by 2, which is our number. So I feel like that's the solution here. So let's get started with coding this up. First things first, we need sum A equals sum A. Second things second, we need to find out if sum A is even or odd. If sum A mod 2 I figured this out the other day. You can do sum A mod 2 without having the equals 1 because it's going to be 1 or 0, so it's like true or false, you know? If sum A equals 1, then it's odd. Then and then our other case else. So if sum A is 1, we can do subtract elements equals 0. Elements equals sum A divided by n minus 1. 11 divided by n is 11 divided by 5 is 2. No, okay. So AVG equals sum A divided by n. We would do That's 2. So then we would need, okay, sum A equals sum A. AVG equals sum A divided by N. Elements equals sum A. This feels very roundabout. Isn't it just N minus 1? Else elements equals N print elements. Can numbers be negative? Okay. Are there any cases we miss? Because this works for 5. 1, 2, 3, 4, 5, 1. 4, 5, 6, 7, 8, 9, 10. This isn't right. 2, 3, 1. Like this. 6, 7, 8, 9, 10, 11. And then our expected output is 4. This is 6 numbers. What the hell? 1, 2, 3. This is 6, 7, 8, 9, 10, 11. There we go. Sum 11 divided by 2, or 11 mod 2 is 1. Therefore, elements is 4, n minus 1. So, right. There could be one element. So, I guess another case would be hey, this fails. Glad I tested this. Okay. If n equals 1, elements equals 1. Okay. What else could possibly break this? I'm just worried about a case where, like what I was talking about earlier. Like, is there any case where we can't make groups, like maybe some case where it's delete this, delete this, delete this, move these here, and then it's like 1, 2, 3. But then you would just like do this. No. 7. 8. Press 4, 4, 4, 4, 4. 1, 1, 1. Yeah, okay, what if it was like 2? Then you just do this. New test case 7, 4, 4, 4, 4, 4, 1, 1. It'd be 1, 2, 3, 4, 5, 6, 7. Okay. Let's just submit it then. Wrong answer on test case 5. Okay, so there can be negative numbers. Absolute value of it. Okay. Yeah, I should have looked at this better. Sure, your answer is 5. What am I getting? 6. So the average. Okay, well, the sum is -1. Which means we do elements equals n minus 1. Six elements minus 1 is 5. How does this look? Okay, so for negative numbers, we draw a line, grab a block, boom, boom, 0, 0, boom, boom. We have 6 numbers, so what we can do, I guess there's this scenario where we just keep pushing 1 in the negative and use it to mark everything else. So we would do boom, 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 and then boom, 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 boom. This makes it slightly harder. So we can always just sack 1 to make all the other ones. This is odd. Wait, I received 6. Why did I receive 6? What is -1 mod 2? This one. We're going here. 6 minus 1 is 5. Is it something to do with the sum? I'm getting -2, so it's even. Okay. Um, this actually makes it considerably harder. Because this logic works for all positive numbers. It doesn't really work for negative numbers. Negative. If it was two negatives, what would happen? So I guess we need to add a check for negative numbers. Okay, the worst case scenario for negative numbers is -1, 1, -1, or it's -2 and 1, I suppose. This can become -1, 0. Like this will never make it. So it'll always be 1. But this will also always be 1. Or this will be 2. It's 2 right off the bat. Sum is -1. Sum is -1. Okay, so sum is -2, -1, 1, -1, -1. Sum is -2. And we can make this. It's just 3 off the bat. Don't think we can make this 4. -2, -2 is even. It's just n. N minus 1. This negative case is making it pretty complicated. Is there a case where we can make it, okay, like -1, -1, 2 could become 0, 1. That doesn't work. -1, 1 becomes 0, 0. Let me think. Why does this work? This is 0. What also works? -1, 2, -1, 0, 1 also works. It's this, right? 0, 0, 0, 4, and then 1, 3, 2, 1, 1, 2, 1, 1, 1, 1. Yeah. So if sum divided by n for all cases, then the answer is n. This is 4. Sum here is 4. 4. Okay. Sum here is 0. 0, yes, can be divided by n. So it's 2. Then the answer is just n. Cases like this where it's sum 8, 8, is 23 is not divisible by 8. We only make 7 groups. Seven groups of 3 is 21. So we basically try the max groups, 8. And we do that by sum divided by n. If it doesn't work, we try sum divided by n minus 1, and etc., etc. Although you can always make sum divided by n minus 1, because as we saw, we can always go into negative. We can always stack 1 to equal out everything. So our worst case is n minus 1. Our best case is n. So you can either make n or n minus 1, which means we can do something like we can keep the sum if sum a mod n equals 0, print sum a divided by n, else print n, else print n minus 1. This fails. Why does this fail? The sum is 8, 8 for 20, 22. How can we make 7 out of this? How did I model this last time? Is it this one? 4, 4, 4, 4, 4, 1, 1. Like this. I don't know what. I don't know why I put expected output as 7. It should be 6. There we go. There we go. Wow. This was quite a tricky problem. You had to realize a lot of stuff. I liked it. Okay. How long did it take me? 32 minutes for 1300. That's pretty good. Alright. 2 bags of potatoes. First bag contains X potatoes. Second contains Y potatoes. Very scattered boys, so the first bag of potatoes contains X potatoes. Very lost. Remembers the total amount of potatoes. Not greater than N. Divisible by K. Help her determine how many potatoes could be in the first bag. Print all such possible numbers in ascending order. YKN. You print each possible value of X exactly once. Print -1. So YKN equals map into input split. All possible values of X. Where, what's the cap for X? X is greater than 1. Oh, X plus Y. It remembers X plus Y. What is X plus Y? Y is second bag. K is... Oh, X plus Y was not greater than N. So N is the max cap. Max cap is 40 and it's divisible by 6. So the first bag could have been... So it's print all multiples of... 6 where 40 minus where n minus y is 30. I'll print out all multiple 6 under n minus y, basically. That's what it's saying. Multiples of 6 as in no, just print out all multiples 6 minus x under 40. Right? This ain't hard. If there's none, print -1. So for I in range, or okay, while I'm gonna do for I in range. In if 12 print 6 it could never be 6, right? So it would be print I times k. Minus 40. Well, we're never gonna make it that far because if I times k minus 10 or minus y is greater than in break. Okay, so we got to 48. 48 minus 10. No, no, no. It's just this. Okay. If I times k less than or equal to y, continue. Print I times k minus y. 2, 8, 14, 20, 26. We can also do like to print equals empty array to print dot append and then print to print star. There we go. And then now we need to deal with this -1 case where if not to print -1, whatever we can do. Wrong answer. So we're failing to append a 10. We're printing out 11, 12, 13, 14, 15, 16, 17, 18, 19, and we break where 10, not there. Is it this? Is less than or equal to y. So but clearly we can be equal to y. We reread the question. It's not that. So we ignore all these. Why don't we ever get to 20? What is n? N is 20. N plus 1. There we go. I'm kind of bad at, like, looking for edge cases, huh? Okay. Took me 15 minutes roughly. We can do one more. 1100 rating. Personal experience of riding public transportation and buying tickets. After a person buys a ticket, he usually checks whether the ticket is lucky. Let us remind you that a ticket is lucky if the sum in its first half matches sum in its second half. Not every ticket can be lucky. Sometimes one look at a ticket is enough to say right away it's not lucky. There's a criteria. An unlucky ticket will say that a ticket is definitely unlucky if each digit from the first half corresponds to the same digit from the second half, so that each digit from the first half is strictly less than the corresponding digit from the second one, or each digit is strictly more than the corresponding digit from the second one. Such bijective correspondence between the digits, strictly less, strictly more. Then the corresponding digit from the second half. For example, 2421 meets the follow. Not be considered lucky. Is greater than 1, 4 is greater than 2. Wait. Each digit from the first half is strictly less than the corresponding digit from the second half. What does that mean? This first, like here, 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 here. Each digit from the first half is strictly more than. So why are we comparing 0 and 3? 1 and 5? When it looks like we're comparing 2 and 1 and 4 and 2. Shouldn't it be either 2, 2, 4, 1 or 2, 1, 4, 2? I don't really get it. Two contains 2 in digits. Okay. Integer in. Then a s equals input. Take it in as a string. Ticket is definitely unlucky if each digit from the first half corresponds to some digit from the second half. Some digit from the second half. Okay? So that each digit is from the first half is strictly less than the corresponding digit from the second half. Okay, so our number is always even, a number of digits because of 2n. So basically all numbers in the first print yes if it's unlucky, print no if it's lucky. So it's unlucky if each digit in the first half is less than some digit in the second half, or each digit in the first half is more than some digit in the second half. So each digit in the first half is strictly more than some digit. So we want the minimum and maximum of the second half basically, and we check both comparisons. So the minimum is 3, and each digit is less than 3, so it's unlucky. And then this one is okay. I kind of understand what's going on. This isn't that hard. So what we need to do is we need to split the string in half, which we can do A equals A, B equals S from 0 to n, and then S from n to the end. Print AB. 2421. Yes, this is exactly what I wanted. Now, max B equals max B. Min B goes min B. For I in A, so we need two flags. We need both the flags to be flagged true to print no. We need, yeah, okay, so call this if I is greater than min B, greater, or if this is less than 5, if less than, if I is greater than the minimum of B, then greater flag true. If I is less than the greatest digit of, or the, wait, If I is greater than the largest digit of max b, greater flag equals true, less than the smallest digit of b, then less flag equals true. I is greater than the largest digit. Okay, and then if greater flag and lesser flag, print no, else print yes. Okay. Wrong answer. Jesus. $133. Expected output is no. We print yes. So okay. It's both 3. We're saying this is a lucky number because okay. So strictly greater. So if all the numbers are equal, then it's lucky because they're not all less than b. All of a is not less than b or greater. Yeah, that makes sense. Wrong answer on 18. So, okay, how can a question have so many wrong answers? Like, so many different cases? Okay. Expected output no, received yes. So what we need to do is print A and B. Min B, max B. Min B is 0, max B is 3. There does seem to be zeros and threes in the first number. Okay, so what does corresponding mean? Like, this is the only thing that could be messing me up, right? Because this code handles all the cases. And this, like, sort of picks a semi-random order. I mean, when I think corresponding, I think this is A, this is B, and then we match the indexes up. It's not all of them, right? Why is this 2421? We'd match them up like this, no? Corresponds to some digit. So we can order these however we want? Is that what I'm hearing? Or, but then there's corresponding digit. This question is terrible. I guess we could sort A and B, like A dot sort, B dot sort. And then like we'll have corresponding digits. But I don't know. Like, how can you use some digit and the corresponding digit here in the same sentence? It just makes no sense. For I and A, we have to do range in if A, I, B, I. A, I, B, I. So if AI is greater than or equal to BI, is strictly less. Let's name these better. Let's call them like strictly less, strictly more. Strictly. Can't spell. Strictly true. By default. No, false. And then if AI happens to be greater than BI, then strictly. Okay, wait, no. It's true, and so this is false. Strictly more is false. If AI happens to be, then strictly less equals false. Wait. If AI is then strictly less is false, else strictly more is false, and then we can have strictly more, strictly less. We reverse these basically. I fucked something up. I fucked something up. Because they're strings. List. It's over. Or. Okay. Think we got it? I do not like this question. We got it. The wording on this question was really weird in my opinion. But, okay. That will be the end of this video. If you enjoyed it, please like and subscribe. And I'll see y'all guys tomorrow. Bye.